Today we're going to talk about functions, relations, and how to evaluate functions. So basically a relation is any set of pairs where the first thing or input is the domain and the second part or the output is the range. And you can compare any two things. Like if you thought about like movie stars and their salaries and you listed the top 10 movie stars and how much they made, that would be a relation because it's a pair of data. You have the name of the movie star and how much they make, that kind of thing. Similarly, like you could have, a list of students and say these are the grades in their algebra class. This is a pair. And so the input is the student and the output is the grade. Again, like cell phone plans, you could compare Verizon or Cricket or Sprint or T-Mobile or whatever, and you say each one of these plans has a particular monthly rate. So that's just a relation. A relation is where you have an input and output, and you look at that information. All right, so here's where we talk about if the relation is actually something called a function. All right, so it's only a function if there's only one unique output for the input, okay? Two inputs cannot be the same. So the way to think about this is thinking about a vending machine. So if you were to own a vending machine, you want it to function properly. You want when people put their money in that they get a snack out that they ask for, okay? So each button that you push on the vending machine should just give you one snack, all right? But if you press a button and you get two snacks, it might actually be your lucky day. But if you're the one who owns the vending machine, you're not really happy about that because people are getting snacks for free. So if it's functioning properly, one button equals one snack. If it's not functioning properly, then one button will give you more than one snack. Now, the alternative to that is that let's say you have this vending machine. You push A1, you can get chips. You push B1, you get cookies. You push C1, you get gum. You push D1, you get pretzels. Now, it would also function if you had another button, E1, that also gave you chips. It's okay if more than one button gives you the output. So more than one input can give the same output, but it would not be functioning if you push one button or one input gave you more than one output. So I always think of it as a vending machine because it's a lot easier to keep track of what things can be doubled and what things cannot be doubled. So basically the input cannot be doubled. You cannot have an input that gives you two different outputs like this one. This is not functioning, but different inputs can give you the same output. That's okay. All right. So this is not a function because it has two outputs, two things come out from the one input. All right. So if you have a graph, a point, a curve, a line, a figure, or whatever on an actual graph, sometimes they'll say, is this a function? Well, we're going to do something called the vertical line test. Now, vertical means up and down. So basically what you do is you look at each of your, whatever it is that you want to evaluate, and you look at the vertical line test. So let's look at the purple line first. Here's the purple line, and we want to know, is this purple line a function? So if you take this straight edge and you say, okay, if I were to draw a vertical line anywhere along this purple line, will it only intersect the line once or will it ever intersect it more than once, okay? So in this case, no matter where I draw the vertical line, it's only going to touch the purple line in one place, so that makes it a function. But if you look at the blue dots, for example, here's the blue dots, these are discrete functions. Then here, if I touch the blue dot, it's only at one spot with a vertical line, one spot. But look at what happens when I get to this point. This blue function intersects the vertical line in two places, and therefore it makes it not a function. Let's look at the red. The red is this kind of zigzaggy line. And so no matter where I draw the vertical line along this red figure, it'll only intersect the figure once. Therefore, it's a function. If we look at the green, here's a circle or circle-ish figure. Right here, it only intersects it once, but if I were to draw a vertical line right here, it would intersect the green twice, and so therefore it would make it not a function. So hopefully you kind of get the idea about what's the difference between a function and a not function with regard to the vertical line test. So if it passes the test, it's a function. If it does not pass the test, it is not a function. All right, so let's look at other representations. Sometimes you're given like a table of points, and this means point -2, 3 on a coordinate grid. So the x is -2 and the y is 3, -1 and 0, 0 and 1, 1 and 2, 2 and 4. So here's a function, and the reason we know it's a function is that for each input or x value, there's only one output. Okay, there's nothing that's repeated here. So this is going to be a function, and when you plot it, it's going to be points, sort of like the brown points. They're all just going to be scattered around. If it's not a function, then you're going to have an input that's repeated. So over here, -2 is repeated. So at -2, you have a 2, and at -2, you have a 4. Therefore, it's not a function. Now, the domain of a function is all the inputs, and the range is all the outputs. Domain are all the inputs, and the range are all the outputs. You always write the domain and the range from lowest on a number line to highest. Okay, so even if it's not listed that way in your data, you will always list it from lowest. 0 is the lowest, then 1, then 2, then 3, then 4. So you would list it in that order. You also don't list repeats. So since -2 and -1 are both listed twice here, you would only list it once in the domain when you're listing that. So let's look at these. These are also called input-output or representations of relations, right? And so this relation says that I can think of this as a vending machine. I push the A button, I get this snack. I push the B button, I get this snack. I push the C button, I get this snack. So it's obviously a function because for each input, there's only one unique output. But it's okay that the B button and the C button give you the same output as long as there's not multiple inputs. The domain are all the inputs, and the range are the outputs. This is not a function because look, when I press this button A, I'm going to get this snack and that snack. Therefore, it's not a function. Again, I list the domain and I list the range in alphabetical or number order. Another way to represent relations is to have a list of points, right? So this was a table of the points, and this is just a list of the points. The domain are all of the x values, and the range are all of the y values, and it is a function because each of the inputs has its own output. But this is not a function because, look, I have a 2 and a 2. It's the same input, but it gives us a different output, and so therefore it's not a function. All right, so let's talk about evaluating the function. And so you can either evaluate the input or the output of a function, and so depending on what you're given. All right, so here it says I'm going to give you this function, f of x is equal to this expression here, and I want you to tell me what would happen if instead of f of x, I want f of -2. Well, if you notice, the x was replaced with -2. The x is replaced with -2, which means the x here needs to be replaced with -2. So I'm just going to put a 2 in where there's an x. It doesn't mean that I'm multiplying f and -2 together. This is just a way to represent functions. So I put in a -2, and I don't worry about the left-hand side. I go ahead and put in a -2 for x, and I go ahead and evaluate. And I notice that when I have an f of -2, or the function has x is equal to -2, the output is -1. This was the input. This was the output. So then sometimes they ask you the other way around. They say, hey, what is the x value if the function is equal to 9? So the whole function is equal to 9. F of x didn't change, just the function. So instead of f of x, I'm going to put 9. So for f of x, I'm going to replace it with 9. I still have the function, so 9 is equal to this. So this is the output, and I want to find the input. So I do this, and I solve for x, and this means that when the function is equal to 9, then x must be 3. You can also think of this as y. F of x can also be thought of as y. So on a graph, in this case, when x is -2, y is -1. And in this case, when y is 9, x is 3. Okay? So let's do an example together. So in this case, they give you a list of points, and they say, hey, what would happen to this function if the x is 3? Well, I go and look for 3 in all of the x's. There's a 2, there's a 3, there's a 4, there's a 5. So when x is equal to 3, the whole function, or the output, is equal to 7. Down here, I want to know what is the input, or what is x, if g of x is 10. So in this case, that means I want the output to be 10. What is the input? Well, x is equal to 4 when g of x is equal to 10, or you can think of it as a y. So this you can think of as being replaced with a y. When is y 10? What is x? And here it's like, when x is 3, what is y? So that gives you the answer that we have here. All right, last couple of problems. We have this input-output relationship. When you have an x value of, you can think of it as x and y's. When you have an x value of 5, you have a y of 4, an x value of 7, a y of -3, and an x of 11, y is equal to 7. So here it says, hey, when x is 7, what is y? So when x is 7, y is -3. Here it says, what is x when y, or the whole function that's represented by h of x, when the whole function is equal to 4, what was x? Well, x was 5. Okay? Let's look at the next one. You have, again, a table of x's and y's, inputs and outputs, and we want to know what happens since the 1 is replacing the x part. When x is 1, y is 0. That's the output. When the output is 1, x is 2, the input. All right? And the last example, here's your function, and I want you to evaluate these two scenarios. Try it and then pause the video and come back and check your answer. All right? So the first one simply asks you to put -2 in everywhere there's an x. So everywhere there's an x up here, you had to put in a -2, and then you just keep evaluating using your order of operations. The bottom one is a little more tricky because you're replacing y plus 1 everywhere there's an x. So y plus 1 has to be squared. Y plus 1 is multiplied by 5, and then you add a 7. Well, when you square a binomial, you get, you have to do first, outside, inside, last, and so you get a whole square term. Then you distribute your 2, and you combine like terms. There's only one y square. There's 2 different y terms, so you add those together, and then 3 different constant terms, and you add those together. All right.